Hi everyone, welcome to my channel, and in this video we are going to discuss the problem set matrix zeros. In this problem we are given an 2D matrix of size m into n, and we are also given that if an element is 0 in the matrix, we have to set the entire row and entire column to 0 in which that element is present. What that statement means is that, let's take the example of this test case. Now let's draw this first separately. Let's say our 2D matrix is 1, 1, 1, 1, 0, 1, 1, 1, 1. So 0, this element in the matrix is 0, and this element belongs to this column of matrix and this row of matrix. So all the elements of this column and this row should become 0. That means this matrix should get converted to something like this. That's how our matrix should look like. Now once we have understood what we should do in the problem, let's proceed to how we should solve the problem. Now we have another example of 4 by 4 matrix. Now to solve the problem, we should first modify the elements of the first row and first column to either 0 or non-zero using the subarray or the submatrix, this one. And this subarray should exclude the first column and the first topmost element of the matrix, especially. Why? We would talk about that later, but we would modify this row, that is the first row of the matrix, and the first column of the matrix using this subarray. On the part y would exclude the very first element of the matrix and the first column of the matrix. Y would exclude them, that we would come back to later. For the next part, how we would actually modify the elements of the first row and the first column of the matrix according to our needs so that we can proceed further is, let's take the same example of the matrix that we originally took before. Now in this matrix, first what we need to do is we have to traverse through the elements of this subarray and see that whenever any one of them is 0, we would make the corresponding row and column first cell of the matrix 0, which contains the element that is 0 in the submatrix. What I mean to say by this is, let's say we started traversing in the submatrix and first we found 1. So the 1 is contained by this row and this column. But since 1 is already non-zero, so we don't need to just keep it, we should skip it. So we move forward to the next element in the submatrix. Now again we just found a non-zero element, so again we skip it and move to the next element. Now when we reach here, we found the element that is 0. Now this element is contained by the second column, the second row and the second column respectively. Now what we need to do here is, we need to change the first cell of the second row and the second column to 0. As soon as we encounter an element that is 0. So after doing this, these two elements will become 0. Now we again move to the next element that is 1, which is non-zero. So we skip it. Then we again move to the next element that is 1, which is non-zero. So we skip it. Now we again move to the next element that is 1, which is again non-zero. So we skip it. Now we again move to the next element. It is again 0. So now what we need to do is, we need to change the first cell of the third column and the third row to 0. This would be changed to 0 and this would also be changed to 0. So after doing that, these two cells would become like 0 and 0. Now we again move to the next element, which is again 0. So what we need to do is we need to change the element, that is the first cell of the fourth column and third row to 0, which would make these two elements 0. Now this is already 0, this element is already 0, so we don't need to change it, but we need to surely change this 1 to 0. So after we do this, it would become 0. Now we again reach element which is 0 here when we traverse again. So now the element, first cell element of the second column is already 0 and the first cell element of the fourth row is also already 0, so we don't need to change both of them. Now coming to the next element, that is 1. So this is a non-zero element, so we skip it, and this is also a non-zero element, so we skip it. So that's how we traverse the submatrix in green and modify the elements of the first column and the first row. Now if we start to observe carefully, we will notice a pattern that whenever we encounter an element which is 0 in the green submatrix, that is this, whenever we encounter an element which is 0 in the green submatrix, we make the first cell, the corresponding row that contains it, also 0, and the first cell of the corresponding column that contains it, also 0. That is what we are doing. Now let me demonstrate to you again what is happening when we write these equations. See, the index of this is 0, 0. This is 0, 1, 0, this element. Now the index of this element is 2, 0, and the index of this element is 0, 1. This is 0, 2, and this is 0, 3. Now if we take this element, originally there were ones in this element. I have deliberately written 1 in place of 0, as it was before 0, I know, but I have already written 1 as to demonstrate again what was happening. So when we encountered this 0 in our green submatrix, so what we did was we replaced this one with 0 and we replaced this one with also 0. So we replaced a2, 0 with 0 and a0, 2 with also 0. Now if we just move a little bit down, the index of this is 1, 2 and this is 2, 2, as we can see. So this makes it, the index of this element is a of 2, 2, and when we encountered it to be 0, we did this. So that's how we are making the elements of the first row and first column to 0 whenever we encounter element in the green submatrix to be 0. Now after modifying the first row and first column of our matrix, the matrix that we will actually find is this matrix. Now once we have done our first task, now what we need to do is we need to keep the first cells of each row and column as a check or flag for the other part of the matrix to check whether these elements need to be converted to be 0 or not. That is this subarray matrix. or this submatrix in green. We will use these first cells of each corresponding row and column that we have modified previously to make the other elements of the matrix 0. So in order to do that, so we would start traversing from the very first element of our submatrix, that is 0, and we would check if the corresponding first element of the row containing it and the corresponding uh, first element of the column containing it, either of them is 0 or not. If either of them is 0, if any one of them is 0, then we would make this element 0. Now in this case this is already 0, so even if we make it 0, it doesn't really affect it much. But now let's see in this case, in when the element is 1. Now the corresponding first cell of the column containing this element is 0. So we have found one element that is 0, and the corresponding first cell of the row containing this element is also 0. So we would modify this element to 0. Either one of them, either the first cell of the column containing this element can be 0, or either the first cell of the row containing this element can be 0. If any one of them is 0, then we have to modify the element to 0. Now we move to the next element 1. Now we see that the corresponding first cell of the element of this row is 0, so we will make it also 0. Let's actually make them 0. Coming to this element, now the corresponding row for this element is this, and from row only we have found that the element at the first cell of the row containing this element is 0, so we have to modify this element to 0. Once we are done with that, let's come to the next element. This is already 0, we don't need to check for this. Now we move to the next element. Now this is also already 0, so we don't need to check for it. So now we move to the next element. Now this is 1, so the first cell of the corresponding column containing this element is also 0, is already 0, so we will modify it to 0. Let's modify these two into 0 because they were not. Moving on to the next element, which is 1. The corresponding row containing this element has its first cell equals to 0, so we would change this element to 0. Now coming to this element, the corresponding column containing this element has its first cell equals 0, so we would change this also to 0. So that's how we are using the first cells of the row and column to actually modify the other part of the matrix. So how we would really proceed to make the elements of this submatrix 0 when we are writing the code for it. So here is also a pattern that we have to observe, that whenever we find an element which is not equals to 0 and the corresponding first cell of the row containing it is either 0 or the corresponding first cell of the column containing it is 0, then we need to make the element 0. That's how things would proceed. Now let me demonstrate this for you too. Now this was our original array that we were left out with, and these two elements were converted to 0, this and this. Let's take this out again from here, make this again. Like in this case, the index of this element is, this is 0, 2, so the index of this element is 1, 2. and the index of this element is 0 comma 2, and the index of this element is 1 comma 0. So as we can see, a of 1 comma 0 is also equals to 0, and a of 0 comma 2 is also equals to 0. Therefore we can say that we can replace a of 1 comma 2 with 0. That's how things are working. Now these traverses that we were doing for this green sum matrix part would start from a11, because this index is 1 comma 1. As we are excluding the first row and first column, that's why we are starting from 1 comma 1. Now after doing these set of operations, first modifying the first row and first column and using them to modify the other part of the matrix, that is the one in the green sum matrix, as you can see, we are getting our matrix like this. Now we compare, when we compare it with the original matrix, now this shows that this one should have been also 0, but actually after this set of operations we are getting it as a non-zero element, which is not favorable for us. So that's why we should also check for the, we will now check for the first column and the first element of the matrix, and also the first row of the matrix, whether they are 0 according to the other elements of matrix or not. Now in order to check for the first row and first column of the matrix that the elements of them should be made 0 completely or not, we would to keep two more variables to check whether they should be made 0 or not. The first variable would be is called 0, and this variable would be initialized to false. It would be a boolean type variable. The second variable would be the first element of the matrix itself, that is a0 comma 0, and whether this element is 0 or not 0, that would determine whether we should make the first row 0 completely or not. This would be our second check. For the first row, and this would be our first check for the first column of the matrix. Now how these checks would work is, I have explained for the a0 comma 0, and why we have taken a0 comma 0, because we never altered a0 comma 0, we left it unaltered from the starting. The procedure we followed has left a0 comma 0 unaltered from the starting. Now for is call 0, it would work like this: if any element of the first column is non is 0, if any element of the first column is 0, then we would change is call 0 to true, otherwise it would remain false. Now how we should proceed to make these two conditions work is, see, before we traverse the rows of the big green submatrix in order to alter the elements of the first column and the first row according to our first task, we would first, whenever we are going to traverse any row of our big green submatrix, we would first check before that if the if in the rows index the first cell of that row is 0 or not. If the first cell of that row is 0, then we would make is call 0 equals to 0, sorry, equals to true. Otherwise we would do nothing and move forward to traverse the elements. Before traversing the elements of any row, we would first check if the element of first cell is 0 or not. So let's see from example how we are doing that. Let's say we came upon this row in our big green sum matrix, this first row. So we would check if 1 is 0 or not. If 1 is 0, then we would make is called 0 equals to true. In this case, is called 0 would remain false, and because 1 is not 0, and then we would start traversing from 2. So 2 is non-zero, so we would skip this element. 3 is non-zero, so we would skip this element. 4 is non-zero, so we would skip this element, and we will not alter the elements of the first row and first column. Now when we come upon this row while traversing the big green sum matrix, after we reach, before we start from 0, we would again check if the first cell of the second row, because this row belongs to the second row, is 0 or not. Is 5 equals to 0? No. So is called 0 remains false, and we would start traversing from 0. 0 is not equals to non-zero, 0 is 0, so we would make immediately, according to our first task, 5 as 0, as the first cell of the corresponding row should be made 0, and the first cell of the corresponding column that contains this element should be also made 0, so 2 would be also made 0. Now here we realize the importance of keeping this check before altering the elements of the rows and columns, because if we alter them before this check, if we alter the elements of the rows and column before this check, then our entire algorithm would have been disrupted. We would not have been able to check for the first column of our matrix. Now if we move forward to 7, we realize it is again non-zero, so we skip it, and we move forward to 8. This is again non-zero, so we skip it. Now when we come to this row, before we actually traverse this row, we would check whether the first cell of this row is 0 or not. Now here we see 0 is unaltered, it has not been affected, and it is already 0. So that's why, since a of 2 comma 0 is 0 from beforehand, therefore we will immediately make score 0 equals to true. Now we would proceed to traverse the elements again like we were doing. These all our elements are non-zero, so we would skip them one by one. Now we come to the next row. Now if we check or not whether this element is 0 or not, that will not affect it much, because already is called 0 has been made true, but still we would check, is 13 equals to 0? No, 13 is not equals to 0. So whatever value is called 0 is containing, it would contain that. Whatever boolean value it is containing, currently it is containing true, so it would contain that. Now we would traverse these elements. Now we arrive upon an element which is 0. So 13 would be made to 0, and the first cell of the corresponding column containing it to be 0. Here it was 4, so we make it to 0. Now how actually would we implement this in the form of our code or pseudocode? Let's actually see it, and I will demonstrate it to you too. Now what is happening is, we first traverse the I from 0 till the matrix length, and then we check for each row that ai comma 0 is equals to 0 or not. If it is, then we make call 0 true, else we do nothing. Then we, for every j starting from 1, because our big green sum matrix first element 0 comma 1, our big green matrix first element is 0 comma 1, therefore we start from j equals to 1 till the number of columns the matrix has. Here I just to tell, matrix dot length only refers to the number of rows that the matrix has, and matrix 0 dot length refers to the number of columns that the matrix has. Now whenever we encounter, after checking this condition from in the starting, that if aij is equals to 0, then we make the corresponding first cell of the row containing it to be 0 and the corresponding first cell of the column containing it to 0. That's what we are doing. Now after we have done this, let me demonstrate it to you also. How is this happening? Originally this element was 5, and when we arrived upon this element, the index of this element is 0 comma 0. One's index is 0 comma 0 0. This element's index is 0 comma 1, and this element's index is 1 comma 0, and this element's index is 1 comma 1. When we write upon this row, before we started traversing this row, we first check that a of 1 comma 0 is equals to 0 or not. Is this equals to 0? No. So is call 0 remains false. And then we started traversing this row. Now once you have understood how we are changing the value of is call 0 depending upon the first column, now what we have to do is, if we find is call 0 in the end of after all the operation equals to 0 equals to true, then we would make the first column of the matrix entirely 0. Why? Because originally if any element in the first column is 0 originally before doing anything, then we should make the entire first column of the matrix 0. Now for the first row of the matrix, what we should do is, we would check that if the very first element of our matrix, that is this is a 0 comma 0 was 0 or not. So if a 0 comma 0 is equals to 0 in the end, because we have not done anything with it, so we would make the first column entirely equals to 0, sorry, first row entirely equals to 0 irrespective of whatever is the state of the first row, whether the elements of the first row are 0 or not. We would make the first row entirely equal to 0 because the very first element of our matrix is 0. Now that's how we would proceed to make the checks for the first column and the first row. Now after we have done all these things, we would ultimately arrive to the final answer. So let's proceed to the code of how the code would work. Now let's first copy this template, which I have already done for you in our text editor. And now let's start writing the code for our program. Now first, we would, as we have said, we would keep a boolean variable called is call 0, and we would initialize it to false. Next, this is a check to ensure if there is any element that is 0 in the first column of our matrix. Now for the first row, the check is a 0 comma 0, which is already the first element of our matrix, so we don't need to keep an additional variable for our check for our row. So now we start traversing the submatrix of our matrix that we set as for our first task. Now for that, we will take an index I, which would go till the number of rows of our matrix, that is matrix.length. And before we start traversing each row of our submatrix, we would keep a check that if the first cell of each row is 0 or not. Because if this is 0, then we have to make is call 0 true. Now we would start traversing each row and change the elements of the first column and the first row. And we would start it from 1 because our sub matrix starts from 0, 1, as we can remember, and it would go to till the number of columns of our matrix. Now after that, we should see if any element in the sub matrix is 0, we would make the corresponding first cell of that row containing this element 0, and the corresponding cell of the first column containing this element also 0. Now we start traversing the smaller submatrix that starts from I equals to 1 and j equals to 1. As we can remember, our second task was to use the elements of now the first row and first column in order to modify the smaller submatrix. Now whenever we come upon an element, we would check that is 0, that is not equals to 0. We would check if the corresponding row containing this element, the corresponding row containing its element has its first cell either 0 or the corresponding column containing this element has its first cell as 0. If any of this is true, then we would make this element as 0. Now we have kept this check is for is called 0. Now we would check if there was any element originally in the first column that was 0 from beforehand. Then we would make all the elements of the first column as 0. Sorry, I started writing A everywhere, assuming the matrix was A, but actually it should be matrix. Let me just change it quickly. Where we should change all the elements of the first column to 0. Now we also have to check if the very first element of the matrix, that is matrix 0, 0 is equals to 0. If this is 0, because we have not altered this element, we have not done anything with this element. If this was originally 0, then we have to make the entire row of the matrix, entire first row of the matrix 0, irrespective of whatever is the state of the first row. Now once we are done with this, now let's check in the main platform if our code is working or not. Now here we have pasted our code from our editor. Now let's see if everything is fine in our code. I think we have checked that everything is fine or not, and to me it seems to be fine. Yeah, it seems to be fine to me. Yeah, one thing, we should change it to matrix here and in the text editor too. This is changed to matrix. Now just let's try to run it. Matrix, oh, here it should be not equals, it should be equals. Let's change it there too. Some small bugs that just make it difficult for you, just small mistakes in our code that we will just wind up with. Yeah, it is working perfectly for this small test case. Now let's check this one, if it is working or not. Let's hope this works. Yeah, this is also working. Let's try to submit our code. Oh, it got wrong answer. There was one small mistake in our code. There was one small mistake in our code that we should keep this check before is call 0. Because if we don't keep this before is call 0, what would happen is that let's say is call 0 becomes true. And if this check was after is call 0, if this check was after is call 0, then the is call 0 has already made all the elements of the first column 0. So if it was originally the very first element of the matrix was not 0, then also this condition would make all the elements of the first row 0. That's why we should first keep this check above is call 0. Now let's just run our code. Yeah, it is working. For let's just run for this test case too. This was getting wrong. I think this is also the only mistake that we were getting. Yeah, now this is also running perfectly fine. Now just let's try to submit it. Yeah, our code got submitted. Although it is showing 2 milliseconds, but I'm ensuring you that this is one of the fastest solutions that can be ever done with, because it is taking just 0.1 space and it is doing the operations in very efficient manner. So let's just submit it again. This is actually fast. Yeah, see, now it is showing 1 millisecond. I told you that it was really fast. It is one of the fastest method to do this problem. Now that was the solution. And let me show you the code in little bit more clarity by taking this whole code that we have just altered with here. We have altered with it here to the text editor. Yeah. Now as you can see the code more clearly now. This is the whole code that we have written, and this is the one that got submitted. Now as you can see, this is the code with more clarity. Now let's come back to our platform. If you found the video helpful in any way, then please make sure to comment and like on this video, and please subscribe to my channel and share this video among your friends too if you liked it very much, so that they can benefit from it too. Till then, goodbye.